All right, let's start off. I'm actually going to start off on number 2 here. So we got 1 and 2 are kind of similar. So number 2, I'm going to want to kind of combine two equations here and eliminate the same variable twice. So it looks to me like the x's would be pretty easy to eliminate here. So I'm first going to go ahead and I'll multiply row 1 by -2. And so then I'm going to combine that with just a regular row 2 here. And so this one will come out to -2x plus 6y minus 2z is equal to -8. And then the second row I'm just going to rewrite. Okay. So what is that? -2. Okay. 6z equals 9. And then we'll add it down. So I get -y plus 4z equals 1. And now I need to kind of do this again with, and I need to include row 3 on this second round. So I'll just do, actually what I'm going to do is I'm just going to do this one as a negative, and I'll just add these straight down here. Row 2, I'm really doing row 2 minus row 1. No, row 2 minus row 3, excuse me. So the 2x's cancel. This will actually turn into -2y because this will actually turn into a +5, and a positive 2z and a -7, and so this will become 8z and 2. Okay, so now I got two equations with two variables, so I'll go ahead and multiply this one. No, I won't. I'll go ahead and multiply this one by -2, so I can eliminate the y's, and that'll become 2y minus 8z equals -2. And so this actually turns into 0 equals 0, which is infinitely many solutions. However, on these ones, I need to write all the solutions, and I always do this kind of in terms of z. So I'm going to take this equation right here, and I am going to actually isolate y, because I'm going to let z equal t, but I want to isolate y and x in terms of t in order to write everything in terms of t. And so I'll go ahead and switch that to a t, and then we will subtract the 4t over. I want to do a cursive t here so it doesn't look like a plus sign. Okay, and then I will divide everything by -1, so y equals positive 4t minus 1. So I have here my point. I know that z is going to equal t. Y will be 4t minus 1. And then I need my x value now, so I'm going to go back to one of the original equations, and I'm going to plug in. I'll go ahead and use this top equation. So I got x minus 3, and then I'll plug in what I got for y, which is 4t minus 1, plus z equals 4. Oh, but shoot, I need to put a t there instead of z. Let me fix that. I'm doing everything in terms of t here. It really is z, but I want to be able to combine like terms in my next step. So distribute that, -12t plus 3 plus t equals 4. And so x minus 11t, if I combine the like terms, plus 3 equals 4, and x equals 11t, and then subtract the 3 over, it would be plus 1. So I get 11t plus 1 for my x value. All right, next up here it says rank the standard deviations and means of the following data sets from greatest to least. So I'm going to do standard deviations first. So standard deviations you should not need to calculate. What we need to know about standard deviation is that the greatest one for standard deviation is going to be the most spread out. And then the least is going to be the most compact data. And so just looking at the data set, I can see that the most spread out is data set B. You can see we have kind of numbers ranging all over the place from 1 to 55. And I would say that the next most spread out is set C. You can see we're going from like 22 to 9. And then the most compact is set A. Kind of everything is grouped there together in the middle. So that's standard deviation. Just think about it, the most spread out versus the least spread out, or the most compact. For means, you have to actually calculate them. I would not make an assumption here. So you're just going to have to calculate them. So, I mean, I think all of these data sets have the same amount of, no, actually they don't. Oh, that stinks. Okay, but anyway, 2, 4, 6, 7. So you just need to do the sum of this first data set over 7. I put the sigma there for this sum. And then for and same idea for the second data set, except I think there are 8. So you're going to have to do, for that one, you're going to have to do the sum divided by 8. And so you have to actually calculate all of those. Just the mean means the average. And so just go for it. All right, next up here, it says we got a class of 40 students, 11 honor students, 10 athletes. 3 of the honor students are also athletes. 1 of the students chosen random. And this is find the probability that the student is an athlete if it is known the student is not an honors student. Okay, so this is kind of a conditional probability here. And so I need to do kind of all the non-honors students on bottom. And so on top, I need the non-honors athletes, since that's what we really want here. But since I've restricted the bottom to non-honors students, that category kind of needs to carry over to the top when I'm looking for the athletes. And so I kind of want to visualize this. So it looks like we have 11 honors students. So then that means if I do 40 minus 11 here, that would give me my non-honors students, obviously. And then for the athletes, let's see, we have 10 athletes in total, but we know that 3 of them are also 3 of the honor students are also athletes, so it's kind of, there's only 3 people that are both here. So I'm going to subtract those 3 out here because I don't want them part of my non-honors athletes. So that's the setup there, so I'll let you guys figure that out. All right, next up here, we got another conditional probability. It says given that they have a 6-period class. So I'm only looking at the 6-period class, folks, so I know my denominator is 23. And then the 1 hour or more of TV is just going to be this one right there, the 13. I'm still restricted to that same category. All right, next up here, I want to solve this system. I would isolate x first because it looks like it's easy to do with no fractions. So I'm just going to go ahead and do that. And then I would plug this in here. Oops. I'm plugging that in for x. I know usually we isolate y. But in this case, we're isolating x, which means we should take x away and leave y there. Okay, I'll go ahead and distribute this. So I get 3y squared plus 8y. I'll go ahead and subtract the 16 over because I already see I'm going to need to factor this. So I'll factor thinking of 2 numbers that multiply to a times c. Now a times c here would be negative 48, and then b would be 8. And so what will that be? Oh, 12 and 4 with a negative 4. And now this one, because we have the 3y squared here, I need to split up this middle term the way I do this. And then I do the factor by grouping. So we get 3y times y plus 4. And this one I got to take out a negative 4 since that third term is negative. And that gives me y plus 4 as well. So I get 3y minus 4 and y plus 4 equals 0. And so I can split those up and equal them to 0 individually to find y, and then you are going to have to plug them back in to find x, but I'll let you guys do that. All right, next up here, we got George. He's got $125,000 to deposit into 3 bank accounts, so I do have the total there, so I'm going to go ahead and add those up and equal it to $125,000. And then we got some different rates here. So I'll attach those to the variables here, and so this is how much money we're getting out of this. And that's going to equal, the total gains is 4.04% of the original investment. So I need to do 0.0404 times 125,000. So that's saying that we're going to make, 4.04% of the total original investment. And whenever you see that word of in a word problem, it usually is meaning multiplication. And so this is going to turn into 50/50. So I'm crossing that off not because I did it wrong, but just because I want to switch that to the actual number there, which is 50/50. Okay, and then it says he has a maximum in account B, which is twice as much as account A. So we do have a comparison equation here. And so I'm going to say x, and then I'm going to put y over here. I should have called these A, B, and C, but x, y, and Z, same idea. And so account B is twice as much. And so I need to multiply account A by 2 to get to account B. All right, so now I would do some substitution here. So I can plug in 2x for both of these y's right here. And so using that last equation, so then if I can break this down by combining like terms, I get 3x plus z equals 125,000. and then I get, let's see, I have 0.06y and 0.01y, so that's going to be, sorry, 0.06x and 0.01x, so that's going to be 0.07x plus 0.05z equals 50, 50. Okay, next up, I would eliminate z because it doesn't have a coefficient here, so I can multiply by negative 0.05, and that'll give me that negative 0.05z that I want, but I do have to do it to everything else as well, so I'll definitely do that on the calculator. This one's negative 6250, and this one will be negative 0.15. So this turns into negative 0.08x equals plus 1550 is negative 1200. And so I will divide that by negative 0.08, and I get x equals 15,000. I could find out, I could keep going here. It's actually pretty easy because I know y is double that. And if any of you are thinking, hey, Mr. Berry, it's already asking for a count A, so you already know that's the answer. Yeah, that's fine. But if you did need to find the rest, I would just plug them back into the easiest equation possible. And then z, let's see, is 125,000 minus 45,000, and that's 80,000. All right, next up here, we're pulling socks out of a drawer, and it does say we are going to return it, so that's a very important aspect of this one. It means it's really independent probability because it's going to kind of reset. So I want the first sock to be blue, so a blue sock would be 8 out of the total, which is, let's see, 24. Yep, and then I want the second sock to be white. So this is still out of 24 once again because we are returning the sock after the first time. If I was not, then that would turn into 23 if I was holding it in my hand. But now this is a 6 since we're looking for the white sock. All right, here we have a table and it says the range is 7. So range is kind of the biggest minus the smallest. And so I know the range is 7, and I need to decide here if x is the biggest or the smallest. Now it says what's the least possible value of x, so that means I want to make it the small one. They could have asked this question being the greatest, and I would have put it in the big spot. And so then what I would need to decide is what is the biggest one here, and obviously that's 11. And so you can just solve that, and that'll be x. All right, next up here, I would use elimination on this one. I would multiply by negative 2, so that gives me negative 2x squared plus 10y squared equals negative 72. And then I would add these two together. So my x squareds eliminate. I get 9y squared equals 81, which means y squared equals 9, which means y equals plus or minus 3. And then I do need to plug both of those in when I am finding x. So I get 2x squared minus parentheses 3 squared equals 153. And then 2x squared minus negative 3 squared equals 153 as well. Now this turns into 2x squared minus 9 equals 153. This one actually also turns into 2x squared minus 9 equals 153. Because we cannot do minus minus plus plus there because it is exponent first. And so I'm actually just going to solve this one time now because obviously those are going to come out to the same answer. So I get 2x squared equals 162, which means x squared equals 9, which, no it doesn't, x squared equals 81. I'm getting ahead of myself because x equals plus or minus 9. And so same thing over here, x equals plus or minus 9. So I got 2 y answers, and each of those gave me 2 x answers, so that gives me a total of 4 answers. I need really every combination of 9 and 3 and negative 9 and negative 3. So that's all 4 of our answers there. All right, next up here, asking you mean, median, and mode. So mean, you're just going to add them all up and divide them by the number of numbers. Median, I do need to put these in order, so I'm going to go ahead and do that now. All right, and then we'll go 7, and then 9, 9, 10. I have to cross them off so I don't forget anything. Okay, 13, 13, 13, and 15. Okay, and then so I just kind of count in here to find the median. And so it looks like we have 5 on each side. We only have one median, and so it is 10. And so I know that answer A is not correct. And then mode is the most occurring one. And so obviously here 13 is the most occurring one. So I can cross off D because the mode is not 8. 8 isn't even on the list. And then so you just need to decide the mean there. I'll let you guys calculate that on your own. All right, next up here, it's asking to describe the distribution. And so I always like draw a picture here. And so I always think, which way would you want to ski down? And so I would want to ski down the right because it looks a little easier. And so we call that skewed right. Sometimes it's called positive skew. Obviously, that's the positive direction. And when this happens, I agree with this that the mean is going to be greater than the median because the outliers actually pull the median to the right. All right, next up here, this one says, let's see. Okay. Okay, so the standard is 20 cubic inches, and then the collectors is 30. So I would call that 20 times the standard plus 30 times the collectors for the cubic inches, and we want to have total of 1870 cubic units. So that's that having to do with the volume. And then the other one is saying 75 copies of the game. So that's just, if I add them up, it should equal 75. So I do not see that right here. But what I do see is I can cross this one off. And although I don't see this exact formula there, what I do see, oh, and you know what? 20S, 30C. Oh, 20S, so this one must be wrong too. And 30S, oh, that one's wrong as well. So, yeah, I did it all based on that equation. If the 20 has to be kind of connected to the S there. So then, why is this first equation correct? Well, you can see that that's actually just a modification of this second equation here. If I subtracted the S over, you'll see that we do get the same thing. So it's not how I would have written it, but you see it is an equivalent answer there. So you do have to watch out for that. All right, next up here, we want to solve this system. So I would use elimination here. So I'm going to multiply this by -4. And so I get -12x minus 4y equals -16. So that's looking like it's going to be infinitely many solutions. Because you can see and everything's going to cancel out. So on the double systems, I always kind of isolate y here. So y equals -3x plus 4, really whichever one you would have done because they're technically the same. And I'm just going to write this as x comma -3x plus 4, and that gives us the list of infinitely many solutions. All right, next up here, it's saying what's the average of number of seeds per apple. Now, very important on this one, we have to realize we have 12 apples here. So I know my denominator needs to be 12 for my average. And I need to take into account here that there's more of certain numbers. So when it says 3 here, that's got to be 3 plus 3 because there are 2 3s, you can see. That's like, think of those as 2 apples that weigh the same amount. And so that means for the 5, it's going to have to be 4 of those. There's nothing in the 4 category, so I'm not going to add that. And so just kind of continue on with that. And notice that it does say closest to the average, so you may get a decimal here, so just however you're going to round it, it will help you decide. All right, next one here, the average. Okay, so it's giving me kind of 3 averages here, and so they want the average then of x, y, and z. I'm just going to kind of write some stuff out here and see what happens. So the x is the average of m and 9. So x equals m plus 9 over 2. So that's what it means to be the average, right? So then y is the average. So y is the average of 2m and 15. And then z is the average of 3m and 18. So z equals 3m plus 18 over 2. So that's how they define this, and then they want the average of x, y, and z. So the average of x, y, and z is obviously x plus y plus z over 3. And then what I'm going to do is I'm just going to substitute all of these fractions in there. Like so. So we got m plus 9 over 2, 2m plus 15 over 2, and 3m plus 18 over 2. And don't forget that that's still all over 3. So then you're just going to have to kind of add those fractions up top. Luckily, they already have common denominator. And make sure you don't forget about that dividing by 3 on bottom. So I'll let you guys take it from there. All right, this chart here gives us, it looks like the median, or sorry, not the median, but it gives us the percent of residents that have a bachelor's degree or higher from 7 particular states. And it says from all 50 states was 26.95 for the median. So what's the difference from the median from these 7 states? So all I have to do is find the median of these 7 states and then subtract them. So I'm gonna go ahead and put these in order. So we got 19.5, 21.9, 25.9, 27.9, 30.1, 35.5, and then 36.4. Okay, great. So I'm going to go ahead and kind of count in here. And it looks like, again, we only have one median. So the median here is 27.9. And so what's the difference between that and 26.95 is all they're really asking here. All right, next up here, it says 100 students, 23 are taking calculus, 29 are taking French, and 12 are taking both. What's the probability that the student is taking calculus or French? And so this is or, which is usually addition here. And it is in this case. So we have 100 students total. And so we're going to add together the 23 taking calculus and the 29 taking French. However, we do always have to subtract any overlap when we have one of these ors. And it does mention we have 12 people of overlap. So they were counted in both categories. So I need to subtract them out once so that they're only counted once. All right, next up here, it says, let A be the event that a car is chosen is American. So the probability that a car is American, that's really out of the whole kind of group here. And so I'll let you guys add up the total. But on the numerator, it would just be all the American cars. So that's just, what is that, 30, 45, 50. So 50 out of the total of all the cars. Now, the probability of A given B is only the compact cars. And sometimes they show given with a bar like this. So I'm going to go ahead and do that. That does mean given. And so now we're only looking at the compact cars. And so for the compact cars, American is still what we want. So I'm going to put the 15 there. And then the total of the compact cars will be 33. And so B and C are kind of similar to that. You have to kind of isolate the given and find your probability. All right, next up it says bag contains 3 red marbles and 5 purple. These are not replaced now. We had a problem earlier where they were. And it says what's probably the first marble is purple, second one is red. So purple on the first one is going to be 5 out of 8. And then I need to multiply that by, I need the second one to be red, but since we're not replacing, our denominator is going to drop down to 7. And we're going to assume we got a purple ball the first time, so that means we still have 3 red balls left over. Next one, number 21. All right, so on this one, we want red and odd numbered. Now, this is just one ball, so I'm only going to do this with one fraction. And so if it's red and odd, I just kind of need to count those up. So 1, 2, and 3. So 3 out of the total of 10. And then it says white and even numbered, really the same idea there, so I'll let you guys figure that out. All right, 22 here. We draw a sock, we don't return it. Okay, the 2 socks we saw are the same color. All right, so actually this one is kind of a tough one, so we need to do black and black, or it could be gray, and gray, or it could be blue and blue, since all of those would be kind of the same color socks. So for black and black, since we're not returning, that's going to be 9 out of the total of 24 times 8 out of the total of 23, since we're assuming we got the black sock on the first draw. So you'll have to do the same thing for grays and blues and then add it all together. All right, next up here it says William is 4 times as old as Ben. So I'm going to say here W equals 4B. Because William is older, we need to multiply Ben's age by 4. And it says 12 years ago, so I'm going to send them both into the past by 12 years by subtracting 12. And then William was 7 times as old as Ben, so now I'm going to multiply Ben's age by 7. And I'll let you guys solve that. Next one here, it says he wants his average to be at least 280 miles per week. And so I would say that we want our average for 4 weeks to be greater than or equal to 280. And so I know that the first week was 240, and then the second week was 310. And the third week was 320. And I don't know the fourth week, so I'm going to put an X there. Now, that answer is not there, but I see that actually this answer is correct, because if I multiply the 4 to the other side, once again here we see it's the correct answer in a different form. 25, I'm going to let you guys try that one. And 26, I'll let you guys look at that one as well. And so 27, all right, so it's saying you got a base allowance of 20 per week. And then and this is the weekly income, so it looks like that you'll get the $20 just once, and then you get $3.55 per hour for chores, so that's going to be 3.55x, and then $17.50 an hour to lifeguard, so that's going to be 7.15y. I'm going to keep those separate because they're really just different jobs. I can't assume I'm going to get the same number of hours at those two jobs.